Let us see how to do the decoding using Viterbi decoder in convolutional encoder. For that you must have the trace diagram of the encoder. So here I have indicated 0/000 means 0 is the input and outputs are 000 like on each line. The details you can find about this in video 1 of convolutional encoder. So for going further for decoding, you must have this diagram with you in your hand. After that, in a problem they give you the code stream, that is received code stream. Here the example is 100 110 111 and 101. So for that you have to find the what could be the input message. So for that you have to first draw these four dots corresponding to each states. Here again I have drawn it here likewise. So first state is always 0, initial state is always 0 0, so this state is 0 0. So when 0 0 is there, you have to see in the trellis or trellis. So the lines are going on this point and this point, and the outputs are 000 111. So what you have to do, you have to draw these lines, this one and this one. Okay, so what is this number? So the output on this line is 000, but here the coded bits are 100. That means you have to find the Hamming distance between 000 and 100. So that could be, so here output is 000 and here the output is 111. So in the exam not needed to write always the outputs, you refer this and directly compute the Hamming distance, because when you always write all these outputs it will become very tricky and it will be hard for you to go further. So I have not written outputs every time, I have just calculated Hamming distance. So 000 Hamming distance is 1. Hamming distance is nothing but at which bits the two streams are different. So 1, here 0 is 0, so difference is 1, 0 0, okay, 0 0, right. So here 1. So what is the Hamming distance here? 111. So it is not 111, I think so. Yes, it is 111. So Hamming distance is 2. 1 is there, 1 0 1 0 1. So Hamming distance is 2. Hamming distance means the counts where the two bits are different. So here 2 times the bits are different. Okay, after that you got these 2 points. So after that you have to go see in the trellis where these 2 points go. That means this and which one is the next point? This one, this and this, where they are going. So again go further, draw these lines, and here these 2 lines. So from here these, and from here these 2 lines. Again see the output, what is the output on those lines, and see here what is your received output, and compute the Hamming distance. So on these lines also Hamming distances are computed. I have written the distances on the line so that it will be easy for us for further calculation. So after that you got these 4 points. Again when you got all these 4 points, this will be copied further. So this is copied and again Hamming distances are found for each output and this 111 output. So in this case, now at this up till this point there is only single branch coming at a point here also. But when you come at this stage, there are 2 lines coming on each point. At that time you have to compare the Hamming distances of 2 branches. So here the Hamming distance is 3, here Hamming distance is 2. So whatever the higher Hamming distance, you have to cut that line. So you are not going to consider that line further. So at each point, so for this line is cancelled. So like this is important step. Whenever two branches are coming, whatever the higher metric is there, I have not done any addition till now. I have just computed the Hamming distance. Here also just Hamming distance are computed, and higher Hamming distance line is cancelled. The same is followed further. Okay, after that, finally you have to compute the sum of all the Hamming distances. At that time you are not considering these lines which are you have cancelled already. So for this point the line could be this one. So total is 2 plus 3 5, 6 7 8 9. Okay, and now let us see what is this 3 for this. So that is not cross actually. I have shown that is the correct output, that's why I have to differentiate it, I have drawn some lines on that was not cross. So this one, this one, this one, this one. For this 4 means this line, this line, this line. Okay, so finally you are going to add all these Hamming distances on this line. So you found that this is the path which is having lower or small Hamming distances amongst these. So that line will be your decoded output. So you are going to follow this path. Now on following this path you have to write what could be the outputs. Now on this line what could be the inputs? On this line the input is 1. Then on the third point, the line going here, the input is 1. Then on this point, that means last point going to second point, last point going to second point, input is 0. Then second point going to third point, second point going to third point, input is 1. So 1 is there. So your decoded output is 1101. Okay, that's it for this video.